Newton's first law of motion says that an object will remain at rest or in uniform motion along a straight line unless acted upon by an external force. But have you ever thought, how did Newton arrive at this law? Have you? Before we begin the discussion on today's question, let me quickly recall that in the very first session we discussed about the mathematical objects that appear in the Newton's laws of motion. In today's session, we want to begin with the concept of force. The idea of a moving force and its effects on the motion of a body was first stated by Aristotle in his famous theory of motion. And it says, every motion requires a moving force and it ceases to exist when the force stops acting on it. Aristotle arrived at this statement by doing a simple experiment. So as you see here, if I apply a force on this eraser, the eraser moves. The moment I stop applying force on the eraser stops. Let me do it again. If I apply a force on the eraser moves. The moment I stop applying force on the eraser, it stops. Simple. So, Aristotle came up with his theory that every motion requires a moving force and it ceases to exist when the force stops acting. Aristotle's theory remained unchallenged for almost 1500 years until Galileo carried out his famous inclined plane experiments. In order to understand Galileo's inclined plane experiment, let us consider two inclined planes which are facing each other, as you see it here. A bronze ball is allowed to roll down from the first inclined plane and then allowed to climb up on the second inclined plane. As he carried out the experiment, he found out that when the ball arrives at the second plane, the height at which the ball rises is always smaller than the initial height. Then Galileo was trying to understand the underlying reason why there is a gap between the initial height h1 and the height h2 on the second inclined plane. Subsequently, Galileo polished the wooden surface of the inclined plane and he repeated the whole experiment. After polishing the wooden surface, Galileo figured out the height h2 is now bigger than the height h2 of earlier setup, although it is still smaller than the initial height h1. So, Galileo argued that one can reduce the gap between h1 and h2 by simply polishing the wooden surface. In other words, the gap between h1 and h2 must have something to do with the obstruction of the surface rather than anything else. So he made a proposition that if there were no obstruction along the wooden surface, then the bronze ball would rise exactly to the height h1 even on the second inclined plane. Galileo then repeated the whole experiment by making the angle of second inclined plane to be different than the angle of the first inclined plane. However, he came to the same conclusion as earlier. Nevertheless, in this case, due to the smaller angle of the second inclined plane, the bronze ball was actually taking longer to rise to the height h2 compared to the time it was taking to come down from the h1 on the first inclined plane. Then Galileo argued that if one makes the angle of the second inclined plane to be 0, even then the ball would try to rise to the height h1 if there were no obstruction along the wooden surface. However, in order for the ball to rise to the height h1, the ball would need to move for infinite amount of time. In other words, if there were no obstruction along the wooden surface, the horizontal motion of the bronze ball would be perpetual. So, Galileo came to a conclusion, what he called the law of inertia, that if there were no obstruction along the wooden surface, the horizontal motion of a ball would be perpetual. That means it would continue to move forever. If you recall, it is precisely the statement of Newton's first law of motion. In other words, although the formal statement of the law was written down by Isaac Newton, the law itself originated from the Galileo's law of inertia, as you have discussed here. Further, Galileo's law of inertia also implied that the Aristotle's theory of motion was wrong, and it was a big statement at that time. Consequently, the Galileo's law of inertia faced a strong opposition from the contemporary philosophers. As you know, later on, Galileo was put under house arrest for heresy of advocating Copernicus' heliocentric theory that says the sun is at the center. I hope you have enjoyed today's session. In case you have any question, comment or suggestion, please feel free to write them below in the comment section. And if you like to follow the physics discussion here, then you are welcome to subscribe to this channel.